less than 50 light-years from Earth. An intriguing world has caught the attention of the scientific community thanks to observations made by the James Webb Space Telescope. This exoplanet, known as LHS 1140b, orbits the relatively close red dwarf star LHS 1140 and has some remarkable features. Although it may be covered in ice, the data suggests it has a vast ocean of liquid water on its substellar side, the hemisphere always facing its star. With a size nearly twice that of Earth, this planet stands out not just for its size, but also for its potential to support life-friendly conditions. The presence of liquid water is a crucial factor in the search for extraterrestrial life, making this exoplanet a highly promising candidate for future investigations. Its unique characteristics offer a fresh perspective on the types of worlds that might exist beyond our solar system and the conditions required to support life as we know it. Recent research based on data collected by the James Webb Telescope suggests that this exoplanet might have a nitrogen-rich atmosphere. This is particularly interesting because nitrogen is an essential component of Earth's atmosphere, and its presence could indicate that the planet has an atmospheric structure capable of supporting a stable and potentially habitable environment. The combination of a nitrogen-rich atmosphere and the possibility of a large liquid ocean makes this planet an exceptional target for future habitability studies. These findings provide a valuable opportunity to expand our understanding of how atmospheres form and are maintained on exoplanets, and the conditions necessary to support life on other worlds. If you're passionate about astronomy and want to keep up with the latest discoveries and discussions about the universe, don't forget to subscribe to our channel. Watch our videos to stay updated on the fascinating world of space exploration and the new frontiers of astronomical science. About 48 light-years from Earth, in the constellation Cetus, one of the most exciting discoveries in the search for habitable worlds beyond our solar system has been revealed by data from the James Webb Space Telescope. The exoplanet known as LHS 1140b is one of the closest we know of, given the vastness of the universe and the great distances between stellar systems. This exoplanet not only stands out for its relative proximity but also for its potential to offer conditions that might be suitable for life. With a size roughly 1.7 times greater than Earth, LHS 1140b is an interesting candidate for habitability studies due to its position in the habitable zone of its star, where temperature conditions are ideal for the presence of liquid water. Ongoing study of this exoplanet could provide crucial insights into the diversity of worlds orbiting stars outside our solar system and the possibility of finding life under Earth-like conditions. This alien world, known as LHS 1140b, is about 1.7 times larger than Earth and has attracted significant interest from the scientific community due to its potential to support life. The discovery that this exoplanet might have an atmosphere and a large ocean of liquid water makes it a notable candidate in the search for habitable worlds. Based on recent observations, there is a possibility that LHS 1140b could be a planet covered by an icy layer, similar to Europa, one of Jupiter's Galilean moons. Europa is known for its icy crust that covers a vast underground ocean, and the comparison suggests that LHS 1140b could have a similar environment, with an icy surface concealing a liquid ocean beneath. This kind of environment could offer unique conditions for life, especially if the ice layer is thin enough to allow the exchange of elements and energy between the ocean and the surface. Evidence obtained through the James Webb Space Telescope, combined with data from previous observations made by the Spitzer, Hubble, and TESS telescopes, suggests that LHS 1140b could be a large icy world with a liquid water ocean and a possibly cloudy atmosphere. Recent data reveals valuable information about the planet's composition and atmospheric characteristics. The cloudy atmosphere might indicate the presence of compounds that could contribute to a moderate greenhouse effect, keeping temperatures within a range that could support liquid water, which is essential for life as we know it. Scientists have strong reasons to believe that LHS 1140b does not fall into the category of mini-Neptunes, as initially thought. Mini-Neptunes are smaller planets than Neptune with thick, hydrogen-rich atmospheres, which does not seem to be the case for LHS 1140b. Instead, evidence suggests that LHS 1140b is more likely a rocky planet or, alternatively, a water-rich planet possibly classified as a super-Earth. This type of planet could have a different internal structure, with a solid crust and an interior possibly composed of liquid water or water under high pressure, which significantly alters predictions about its habitability. The discoveries about LHS 1140b offer a fascinating insight into the diversity of worlds that might exist in our stellar neighborhood. The presence of a nitrogen-rich atmosphere suggests that the planet might have atmospheric conditions similar to Earth's, which is a good indication that it is located in the habitable zone of its star. This zone is a region where temperature conditions are suitable for the existence of liquid water on the surface. The fact that LHS 1140b orbits a low-mass red dwarf star is a crucial factor, as these stars have a longer and more stable lifespan, which could provide a more stable and life-friendly environment over billions of years. This combination of factors makes LHS 1140b an exceptional candidate for future studies on the possibility of life on other worlds, and helps expand our understanding of the types of environments that can support life outside our solar system. However, it is crucial to remember that the presence of habitable conditions on a planet does not necessarily guarantee the existence of life. The definition of a habitable planet refers to its position in the habitable zone of its star, where temperature conditions allow for the existence of liquid water, as well as having an atmospheric and geological composition that could favor life. Even if these conditions are favorable and increase the likelihood of life, they do not guarantee that life is actually present. Life, as we know it, depends on a number of additional factors, including atmospheric chemistry, climate stability, and the presence of other essential elements like carbon and oxygen. Therefore, ongoing research remains crucial to better understand how these conditions might align to create environments where life could emerge and thrive. The team of scientists who analyzed the atmosphere of the exoplanet LHS 1140b highlights the importance of detecting atmospheres on small, rocky planets, a challenging but crucial task for astrobiology. Identifying atmospheres on smaller planets is more complex compared to giant planets due to their lower brightness and the reduced thickness of their atmospheres. Despite these challenges, LHS 1140b stands out as one of the most promising candidates among small exoplanets in the habitable zone. The possibility of a thick atmosphere is particularly significant, as it could indicate the presence of life-supporting conditions. One of the scientists on the team stated, "We might have found evidence of air on this world," which is an important step towards confirming the presence of a nitrogen-rich atmosphere and other essential gases for habitability. Estimates based on available data suggest that LHS 1140b is less dense than would be expected for a rocky planet of similar size to Earth. This implies that around 10 to 20% of its mass could be made up of water, leading to the hypothesis that the planet has a large liquid ocean, particularly in the substellar region where the planet's side is always facing its star due to tidal locking. This scenario is similar to what is observed on icy moons like Europa, but on a planetary scale. The atmospheric analysis of LHS 1140b suggests that the atmosphere could be rich in nitrogen, which would contribute to conditions that favor the presence of liquid water. Atmospheric models indicate that, if LHS 1140b's atmosphere were similar to Earth's, the planet could resemble a snowball Earth, with a central ocean about 4,000 kilometers in diameter. This represents an area roughly half the size of the Atlantic Ocean, with surface temperatures potentially reaching around 20 degrees Celsius. These conditions make LHS 1140b an exceptional candidate for studying habitability, as the presence of a liquid ocean and a suitable atmosphere could create a life-friendly environment. The discovery that LHS 1140b may have an atmosphere and be in the habitable zone of its star offers a unique opportunity to study potentially habitable worlds. Its position in the habitable zone and the likelihood of an atmosphere capable of retaining heat and supporting a stable climate are critical factors in assessing habitability. Ongoing research could reveal further details about the atmospheric composition and other essential characteristics for life. As one of the researchers stated, this is the first tantalizing glimpse of an atmosphere on a super-Earth in the habitable zone. Compared to other exoplanets, such as those in the TRAPPIST-1 system, the star hosting LHS 1140b appears to be much calmer and less active. This significantly reduces the challenges faced by the planet's atmosphere in managing stellar flares and sunspots. However, further observations are needed to confirm the atmospheric composition and to search for other gases that might indicate habitable conditions. Despite this, LHS 1140b already stands out as an important candidate for future habitability studies, offering new hopes and directions in the search for life beyond Earth. The discovery of an atmosphere on a rocky or icy exoplanet in the habitable zone represents a significant advancement in space exploration and astrobiology. It brings us closer to answering the fundamental question about our solitude in the universe. Are we alone? Each new discovery like LHS 1140b not only expands our understanding of the types of worlds that exist but also of the possibilities for life in other parts of the cosmos.